Hi guys. Yeah, actually, sorry for the delay. Yeah, right. So, are you able to hear me? I hope you are able to hear. Hi, Steve. Yeah, Abhiniti and Ritika. Thanks for joining. So please share this link to other friends as well, so that they can join the live. So within 1 minute, I will start this session. What do you say? Industrial products, and then uh, biogas production. Okay, right. So let's start the next aspect. So this video is regarding the detailed explanation on CBSE 12th standard and 11th standard chapters, and this video is regarding 10th chapter, that is microbes in human welfare. Right, this is part 2, which contains two aspects we will be dealing. One is industrial usages, right? So yesterday we dealt the previous video we dealt with the household uses of the microbes. So when it comes to industrial products, so why we say industrial products is that in household products we use certain at certain limit we produce those products, right? So for to meet further demand, or to meet the what is a uh, to supply it to the larger population, or to the larger numbers, we need to produce these products in large scale. So that's why we use different industrial plants to produce, or manufacturing units to produce this sort of products at industrial scale. So when we talk about industrial products, we apply different methodologies. So when we talk about methodology of this production of industrial products can be of you know uh, three types, right? Which is in NCERT this was not covered. So what are the methodologies that we can use to get these industrial products in larger scale, or what are the different types of methodology we use? For that matter, we have you know yeah, okay. So if you see here, there is one at one end we have got laboratory scale, and at one other end we have got industrial scale. So in between we have a pilot plant scale. So these are the three different scales that we can produce these industrial products. So that right from the laboratory scale to manufacturing unit, we will be scaling up the process. So this is what we call scaling up, and the scaling up requires a setup of or they have to be pilot studies also, pilot plant scales also we need to be taken care of. So this aspect, methodological aspects, are not covered in NCERT. Directly what they cover was like what are the products that we produce at industrial level, right? So if you see here, so first aspect is laboratory scale. So what is actually laboratory scale? So if you see this, if you take this penicillin, right? Penicillin notatum, and this the production of penicillin at laboratory scale, right? It would be limited to petri dishes and with that we will not get enough amount of the product, right? So we need to test these, you know, the next phase, that is pilot plants. So what are the conditions does these microbes are well grow? So those are the things that we actually test, or optimal temperature, pH, aeration, etc., will be actually tested in a different fermenters, right? So ultimately, then after getting the optimum production and then separation of product and its purification, then only ultimately the laboratory scale process will be finalized. Okay, so these are the aspects that cover in laboratory scale. So in laboratory scale, what we do is we will test for its optimal what is a production, at the same time what is a temperature, pH, everything. We will all the parameters of this process should be worked out to produce the required or desired products at the laboratory scale. Then we will go to the next pilot plant scale, which is an intermediate stage between laboratory phase and manufacturing unit. So in this intermediate state, where the laboratory scale process will be there, right? The process which we actually standardize at the laboratory, that will be again tested for its cost and qualities, and eventually it will be evaluated. Okay, so the in laboratory scaling method, we use glass vessels to actually produce these products that will be replaced by metallic containers. So again, those containers where fermentation will be carried out, and these fermenters we call it as bioreactors also. So in this we have to see different aeration system, pH corrections, temperature adjustments as preferred, and they have to be met some criteria. So this is what pilot plant looks like. So this is the second aspect, right? So we are talking about the industrial scale. So in industrial scale, right? In industrial scale, from the laboratory unit to the manufacturing unit, right? So what are the different methodologies we can apply? So first one is laboratory, and then pilot, and then manufacturing unit. So in the laboratory, we use glass vessels to produce the products, and we test for its products, etc., different parameters, conditions. And then pilot plant, we replace this glass containers with the bioreactors, which are metal containers, and then we will go for the manufacturing unit, which in this manufacturing unit, it will be, the cost and evaluation is taken care in the pilot study, right? Based upon that, this manufacturing will be set up, right? So based upon the scaling process, pilot plant scaling process only, this manufacturing unit will be set up. Okay, so if we go into the details of this fermenters, in biotechnology lesson we covered this fermenters, bioreactors and their processes, and the stirring types of bioreactors, etc. So now we don't want to go in details of this, and when we talk about the biotechnology, we will come to that part. So let's move to the next aspect, that is, what are the products that we see in this antibiotics? I mean, what are the products that we see in this industrial products? I mean, the microorganisms would produce what type of products, right, under industrial products. So if you see that, what are the different products we talk about is antibiotics. Saran Rakab, hi. So are you able to follow? Just a minute. Sorry. Yeah, night times little adjustment problems. Sorry. Okay, let's move forward. Yeah. If you see this, industrial products that what we're gonna talk is they are about antibiotics, right? You see these antibiotics, right? The first antibiotic we know this Alexander Fleming accidental discovery, etc., penicillin notatum, right? So even the Alexander Fleming got uh, the, was awarded Nobel Prize as well. So that is the first antibiotic ever since we got, and then later on there were hundreds and thousands of antibiotics, discovered later after the discovery of this penicillin. So we know these antibiotics can be of broad spectrum and narrow spectrum, right? So based upon the target they kill or the effectiveness they have, so they can be divided into broader spectrum or narrow spectrum. Narrow spectrum is something which is very specific. Okay, specific to certain organism. Broad means the same antibiotic can be used for different organisms to kill them, right? Harini, good evening. Yeah. So what we are able to see here is 1 minute. Okay. Sorry. Yeah, first got a message. Right. So if you see in these antibiotics, like these are the one of the products we get in, at larger scale we produce at the industrial level. So we use this antibiotics like which are produced by microorganisms, right? When we talk about production of antibiotics, right, they act on, they have a different mode of action. For example, if you see penicillin, right, we got it from penicillium notatum, right? Action on this, we can use this antibiotic, against few diseases to treating few diseases or infections like tonsillitis, sore throat, gonorrhea, rheumatoid fever, and some pneumonia types. So antibiotic, its source, right? You can make a tabular form and you can go ahead with. There are hundreds of antibiotics, but few you would have keep hearing about few antibiotics regularly. For example, neomycin, kanamycin, streptomycin, right? Chloramphenicol, right? These are the antibiotics which we regularly listen, right? We hear about them, and even regularly we use. Sometimes our elderly people also uses these antibiotics. So that point of time, you just take the strip and see what is the composition, right? And then you can Google it, and you can even you can understand. You can even go back where exactly the source of this antibiotic also you can see, and at the same time when you buy an the entire box, right, they give some the description and mode of action also, right? In the when we talk about ointments or some antibiotic vials or some tablets, if you see that boxes contains a description part where you can see all these details. Okay, so this is one example, penicillium, and then we have streptomycin. Streptomyces is the source of this streptomycin, and it can be used to treat meningitis, pneumonia, tuberculosis, TB, right, and local infections. Like that, we have other antibiotic that is chloramphenicol. Chloramphenicol against streptomyces, right? It can actually can be used to treat the typhoid, whooping cough, etc. And tetracyclines are actually again they are produced by the streptomyces, where again we can use it against typhoid or whooping cough, etc. Tetracycline we will be using for viral pneumonia and osteomyelitis. Okay, so what you have to remember is that the antibiotic name and its source and its what you say, which disease we can use it. So these details were not given in NCERT text, right? But while you are reading for NEET, right, these are the aspects that you can really work on. Okay, so these are the few examples that we can talk about antibiotics, right? Yeah, and then, so what are the uses of this antibiotic? If you see, right, these antibiotics are used as medicine for treatment of number of pathogenic or infectious diseases, right, like plague, typhoid, tuberculosis, whooping cough, diphtheria, leprosy, etc. So these antibiotics are very much useful. So these are all again produced by microorganisms, right? So that's what we produce in a larger scale so that we can meet the demand. So these are the aspects of the antibiotics. So within this industrial products, we have one more type of products that we discuss. Few more types we will be discussing. Those are chemicals, enzymes, and other bioactive molecules. Okay. So what are the chemicals that we talk about? In this, in this products, the chemicals like organic acids we will be talking about. So organic acids, again, there are different types of organic acids will be there, right? And enzymes and other bioactive molecules, right? So what are these actually? So how these microorganisms would produce, which organisms would produce, and what are the products they produce is what we will talk in this aspect. So microbes are being used for commercial and industrial production of certain chemicals, right? Like this, organic acids, alcohols, enzymes, and other bioactive molecules. When we talk about organic acid, we have examples like acetic acid, citric acid, lactic acid, butyric acid. So all these different types of acids are produced by different microorganisms. So as in human, right, we are exploiting the very nature of the microorganisms, and then we are using for the human welfare, right, for different purposes. For example, if you see this acetic acid, right, acetic acid is prepared from fermented alcohols with the help of acetic acid bacteria, right? So this acetobacter acetype. So you have to write, you have to, when you, if you're taking notes, right, you have to write, put, it's you can put an heading organic acid and type of organic acid, and then corresponding acetobacter aceti is the organism which produces acetic acid by anaerobic process, right? And then, so where we use this acetic acid is we use no, we use as an vinegar when it is ripened, right? So you would have heard about vinegar, right? This vinegar can be produced by acetobacter aceti. So in the name itself, it is there, right? So it is easy to remember as well. Acetobacter aceti, acetic acid. And then coming to the next acid, that is citric acid. So citric acid is actually obtained through the fermentation carried out by the Aspergillus niger or mucor species. So this Aspergillus niger would ferment, and then the citric acid would be, produced. So this citric acid has got a nutrient, what is there? Where we exactly use this citric acid, right? So citric acid can be used in dyeing process or medicines, inks, flavoring and preservation of food and candies. So the citric acid has got these many these many uses that we regularly ignore, but these are the products which are produced by the microorganisms, and especially when it comes to citric acid, it is produced by Aspergillus niger and other mucor species. So it is nothing but fungi, right? So this is the second type of organic acid that we are discussing. So first one is acetic acid produced by Acetobacter aceti, and then now we are talking about citric acid. Citric acid is produced by Aspergillus niger, right? And then other mucor species. And then next is lactic acid. Again, this lactic acid name suggests that it is produced from the lactobacillus, right? So how it is produced? This 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 because of the microbial fermentation, right? So what happens is this lactic acid, you know, fermentation can be carried out by both the bacteria and fungi also. So when we talk about bacteria, Streptococcus lactis is where this lactic acid is actually fermented, and fungi rhizophus. So this acid is derived from fungal sources, right? And it has got high purity as well. So where we use this lactic acid. So even this when we talk about this lactic acid production in the bacteria, right? Lactobacillus species can produce this lactic acid. Okay. So this glucose would be eventually fermented to form this lactic acid. So this lactic acid is used in confectionery, right? Fruit juices, essences, pickles, whatnot. You take lemonades. So it has got different usages in the food products. So this is one more acid, that is lactic acid. And then one more acid that was given in NCERT text is butyric acid, which is produced by Clostridium estobutyllicum, right? Clostridium butylicum or Clostridium estobutyllicum, which produces this acid that is called butyric acid. So it's rhyming with the organism name itself, butyric acid estobutylum, right? Clostridium butylicum. So these are the different acids. Organic acids are produced at the industrial scale, right? And then when we talk about alcohols, we can produce ethanol, methanol, propanol, butanol. These are all alcohols can be produced commercially by by fermentation activities. So when we ferment certain raw materials by fungi, for example, if it is a fungi like yeast, Rhizopus mucor, if it is a bacteria, Clostridium estobutylum, or we can even use Saccharomyces, where they produce this different alcohols. For example, ethanol, right? We use this as a spirit also. So crude ethanol, etc. Right? So these are all produced by the organisms as well. So they are used as industrial solvents. So these alcohols are used mostly. You would have seen in your 12th standard experiments, right? We will be using this ethanol, right? So they will be used as solvent. For example, if you wanted to do any chromatography in thin layer chromatography in your chemistry practicals also, we use different solvents. So methanol, propanol, these are all the solvents we can even get from this microbes at industrial level. Is that clear, guys? Are you able to follow? Are you able to follow, guys? Yeah, okay, fine. So the next aspect is what we're going to discuss is enzymes, right? So these enzymes, okay, again, these are all gene products, right? So these enzymes are produced by gene expression, right? The DNA expresses mRNA, mRNA undergoes translation to produce the protein, and these all enzymes are proteins, right? So these enzymes which can be produced by even microorganisms. And now we will be talking about different types of enzymes that we use in different types of purposes. For example, proteases, pectinases, if you see this proteases, or they will be acting as clarifying agents. Like clarification is nothing but the fruit juices. If you see the fruit juices packed in fruit juices, if you see, they'll be very much clear when compared with the what do you see, fresh juice. So how is that possible? Is that because of usage of these enzymes which actually clear that solution, right? So this is one of the uses of the proteases, right? So what exactly the function of proteases? The proteases actually degrade these proteins into polypeptides. So complex proteins would be degraded into simpler polypeptides, as simple as it. For example, even they can be used in manufacturing of detergents, where it is capable of removing any proteinaceous stains. As so this proteinaceous stains, if anything is there, so we can use this proteases to actually remove these proteinaceous stains. Like that, we can even talk about lipases, right? These lipases can act on lipid molecules and they can break down into simpler forms. And again, these oil stains also can be removed by these lipases. So actually, according to the NCERT, this proteases and pectinases are commercially used to, clear this fruit juices, right? Clarifying agents. And the lipases, just now I told that they can be used in the detergent formulation, where we can actually remove any oily stains from the laundry. And then next one, we'll be talking about the cyclosporin. The cyclosporin, if you see this cyclosporin function, right, it acts as an, you know, a cloth buster. So it can be, produced by fermentative activity of trichoderma. So this cyclosporin has got even what is it? Yeah, 1 minute. So what about remaining? Yes, sir, able to follow. Fine. Yeah, I think remaining, that's okay if you are following, that's well and good. Yeah. So we are talking about cyclosporin, right? So cyclosporin A, which actually acts as an anti-inflammatory and immunosuppressant, not the clot. It will not act on any clots, or not clot buster. Actually, clot buster is actually, uh, you know, uh, what is it? Which the streptokinase actually, which is extracted from this produced by the streptococcus, which is genetically modified, engineered, which can be used as clot buster. Please do correct, right? This clot buster, which actually clears the clots in the blood vessels, is nothing but the streptokinase, right? Which is produced by the bacterium Streptococcus. And then we will be talking about other bioactive molecule, that is cyclosporin A, which is used as an immunosuppressive agent. So now we are talking about the industrial products that we see, and these industrial products we are so far we talked about different products. So we talked about you know organic acids, right? Anti-organic acids, enzymes, and now we are talking about other bioactive compounds like streptokinase, right? This is plasmogen activator. This is tissue plasmogen activator. So an enzyme which is obtained from the hemolytic bacteria, that is streptococcus. So hemolytic means which breaks this blood cells, right? So then it is genetically modified to function as a clot buster. Okay, fine. And then we talked about other enzymes like pectinases, lipases, and peptidases. And then now we will be talking about the cyclosporin A, which has an important functions like antifungal, anti-inflammatory. At the same time, it acts as immunosuppressive. It acts as immunosuppressive agent as well. So it actually reduces the possibility of graft rejection. Right, when the organ transplantation is taking place, these grafts should not be rejected. So for that purpose, these grafts held in place or without any reactions, this cyclosporin A would actually lowers or suppress the immune system. That's why they act as immunosuppressive agents. And then we have other products, industrial products that we speak about, or nothing but statins. The statins which are produced by the yeast, right? So they actually lowers the blood cholesterol level. So if you see this statins, these are the products of fermentation activity of yeast, right? These are the products. These are the statins are produced, or they are obtained by fermentation process of the yeast. Purpurius, right? This we have this organism here is Monoscus purpurius, right? From where we get this fermented products. Those are statins, right? So these statins would inhibit cholesterol synthesis. Okay, so if you go in depth, right, how do they actually intervene with the functions of the production of or synthesis of cholesterol? So they act as competitive inhibitors. So naturally, some molecules, some enzymes would be there, right? For example, HMG CoA reductase. So this enzyme is reductase enzyme is essential for production of this cholesterol synthesis. This that will be competitively inhibiting these interactions. So what happens is the cholesterol synthesis will come down. So that is how this competitive inhibition will takes place, and eventually the cholesterol levels would be coming down. So this inhibits the cholesterol synthesis. So statins are therefore used in lowering blood cholesterol. For example, lovastatin is one of the example we use. Lovastatin, pravastatin. So these are the different statin molecules, so bioactive molecules we use to lower the blood cholesterol, right? So with this, what we completed is the different chemicals, enzymes, and other bioactive molecules which produce in industrial scale. So will these enzymes like produce causes side effects? No, no. When they are used in detergent and then when they are dried, right? So there won't be any problem at all. Or when you talk about this clarifying agents, right? I think you are talking about clarifying agents. So the concentration they use would be very much less, and obviously they have to be checking the quality of aspects of this food products also. So definitely there won't be any side effects, right? So these are the important aspects of the industrial products, and now we'll try to complete the next aspect, that is biogas production. Where that is 10.4. So far what we dealt is 10.2, and 10.3 will be dealt tomorrow. So 10.4 will be NCERT 12th standard textbook 10.4 that will deal with the microbes in production of biogas. So how we use this microbes in production of biogas. So if you see this biogas production, so this biogas can be used as an uh, as a fuel, right? Which we can actually replace this fossil fuels actually, right? So this biogas can be produced, right? And this biogas is nothing but a mixture of gases which contain high amounts of methane, and this is produced by microbial activity. So if you see this biogas production, the bacteria we use here to produce biogas is nothing but methanobacterium, or sometimes we call it as methanogens, which actually lives in harsh environments. So these methanogens actually, or like methanobacterium, can be used, to actually produce this biogas. So the two. So if you see this methanobacterium, even in sewage treatment plants, sewage treatment anaerobic sludge digesters also, we may find this anaerobic. We can use this anaerobic bacteria to produce biogas as an side product of the byproduct of the biological treatment in sewage treatment plant. That will be discussed tomorrow. Okay. So in this process, this methanobacterium actually eventually, what do you say, acts on cellulosic material present in the food of the cat. So if you see this, first these methanogens are actually identified, right, or observed in ruminating organisms, like the one who actually eats up a lot of cellulosic content, grass and cellulosic content, and they regurgitate, right? So they actually ruminate this cellulosic content, right? And these organisms will have a rumen, right? It's a part of stomach of a cattle. So a lot of cellulosic material which is present in that food, which eventually eaten up by this cattle, right? Which would be actually sent to the rumen. So in this rumen, you will find this bacteria, and this bacteria would actually break down this cellulosic material, right? And it would provide some nutrition to the what do you say, this cattle as well. So once this process is, once this aspect is done, this digestion, partial digestion, or digestion is of the cellulose is done, then this excretion will take place, and this dung of a cattle, right, which we commonly call it as gobar. That's why even we can call this biogas as gobar gas. So why we call it gobar gas is means it produces n number of this methanogens in the what do you say, in the dung, cow dung, or the cattle dung as well. So this excreta, which will be used as an inoculum, right, for this entire process, so that we can use, you can collect this entire dung, and then with the other raw materials and organic, material, we can actually use, use to produce this entire, uh, if you see any uh, these biogas plants, right? These biogas plants are of two types, right? One is cementing type of biogas plants, and other one is you'll find floating type of biogas plants. So when the biogas is produced, the lid would be floating, right? Steel type, and the other one is cementing, which is fixed. So there will be a raw materials along with the cow dung would be actually sent into the almost 10 to 15 feet under the ground. These tanks would be constructed, and these tanks would have, would be fed with all these different types of what is the raw materials, right? We call it as, slurry. So this slurry of bio waste which we collected would be actually introduced into this what do you say, biogas plants. So this biogas plant would eventually would be having inputs, right, inlets and outlets. So outlet will have this even we will be having the collectors pipes connected to this biogas plant, where it would be removing the gas and would be collecting and storing. And at one end we will be having dung and water, the mixing of slurry, and it eventually goes into the digester, anaerobic digesters, right? So once it is getting digested, right, once you are feeding this biogas plant, the excess of the sludge can be entering into the one more partition, right? So that it will stop the overflow. So likewise, we will manage this entire quantity feeding to this biogas plant. So once this digestion is happening by this methanogens or microorganisms, eventually this biogas products would be forming. So likewise, this biogas, if you see this biogas plants, so they will be actually mostly you will be finding in different types of biogas plants, like fixed dome cementing or floating drum type, like they will be floating when the biogas is produced, or even balloon plants will be there, horizontal or earth pit plants. There are different types of bio plants out there, but at the same time this they hold a specific what do you say process. What is occurring is that these organisms are digesting this is acting on this uh, you know uh, the other components, the raw materials that we are feeding into the biogas plant. For example, bio wastes, right? These are all would be sent into the uh, in this biogas plant. So especially that's why we see this biogas plants in mostly built in rural areas. Why? Because you will be finding more cattle and dung as well as the bio waste, so that you can produce this biogas in a larger scale, so that this plant can be directly connected to the kitchen, so that you can use this biogas for cooking purposes as well, or even lighting purposes. So that's what this technology was actually developed by India, right? By different institutions. So these institutions names and shortcuts are very much important when it comes to this type of examples. For example, IARA and KVIC. So, for example, Khadi and Village Industrial Commission, these are all set up different biogas plants and include this technology in India across different rural areas. So, this is how we can produce biogas, and which we can use these microorganisms to digest these unwanted bio wastes, and we can produce a suitable, usable products, and then we can use it for different purposes. So that's what the microorganisms are not always harmful, but these are all useful aspects of the microorganisms. So with this, we completed both 10.2 and 10.4. So tomorrow we'll be taking up the 10.3, right? And we'll see how far we can go. Okay, hope hope this briefing of this, or hope this detailed explanation, because this is more of not much details are covered in even NCERT. So it would be it's a very general topic. When we talk about something processes, for example, photosynthesis and other reactions and other pedigree analysis and different, I will be coming up with some more interesting problems, questions, etc., so that we can have better interaction. Okay, so I just wanted to start off with what I have so far, the time and other resources. So let me. It will take one or two more videos to actually standardize the timings and the content here. So don't get disappointed if you are not able to really utilize the entire things what I'm discussing here. Even I feel that I wanted to put more inputs here, but this lesson is very much limited. So when we take up the other lesson, you will find the difference and you will definitely enjoy better than this. So I hope you enjoyed this class, and thank you for coming live. For the live chat, and thank you for participating here. And please do share to with your friends, and make this video reach every student, so that whoever studying biology, whoever interested in biology, so please do consider subscribing this channel, and like before you leave, and share as much as you can. And thank you guys. This is it for today, and meet you tomorrow. Stay home, stay safe. Thank you guys. So we'll meet tomorrow with the Thursday won't be live, won't be there. Thursday and Sunday there won't be any lives. So we'll meet on the next day. Okay. Today is Wednesday, so we'll meet on Friday. Thank you guys. See you in the next video.